So here's an example of a problem where there is heat exchange between two objects, right? 22 grams of an unknown substance at 0 degrees Celsius is added to 250 milliliters of water at 75 degrees Celsius, and the final temperature of both is 70 degrees Celsius, okay? Now, notice when you put the substance in the water, they have to come to the same final temperature, so it's going to be 70 degrees Celsius. Calculate the specific heat of the substance. All right, so I'm going to start out with a drawing here, okay? And let's say that our substance is in the shape of a square, whatever, okay? This is at 0 degrees Celsius, and the water out here is at 75 degrees Celsius. So water is actually going to go from outside to inside, okay? Heat is going to be transferred from the water to the unknown substance. All right, so if one of the things that's pretty helpful with these is to make sure you know where you're going. So my sentence that I like to come up with is heat is lost by blank and gained by blank. Okay, so if we say that this is our system, okay, and the water is our surroundings, heat is lost by the surroundings, okay, or the water, and gained by the system, or the unknown. All right? So now I like to come up with some signs of things. All right? So QH2O, because there's going to be the temperature of the water is going to decrease. So the final temperature is going to be lower than the initial temperature. So when you do the delta T, you're going to get a negative value. So that's going to be negative. And the Q of the unknown is going to be positive. And due to conservation of energy, okay, I can start with this mathematical representation of the conservation of energy. So Q of the unknown equals negative Q of the water. Okay, this is your golden ticket, my friends. This is where you always start. Okay, start with the conservation of energy. Conservation of energy statement. Okay, this is very, very important for problems where heat is transferred. Okay, so I'm going to start with my conservation of energy statement, and these are just both going to undergo a temperature change. So I know that Q of the unknown is mCp delta T, and I know that Q of the water is mCp delta T. All right, so I just want to make sure that I get my subscripts in correctly. All right, so the mass of the unknown times the Cp of the unknown, and notice this is what we're trying to find, times delta T of the unknown equals, don't forget this negative here, negative mass of the water, Cp of the water, okay, which I'm going to switch over just in the interest of keeping this short to W, Cpw, and delta T W. All right, now because I'm at this point, I can divide by mass of the unknown, delta T of the unknown, both sides. So Cp of the unknown equals negative mass of the water, Cp water, delta T water, over mass of the unknown, delta T of the unknown. This is a very important point to get to, all right? This right here is probably worth 8 points on a problem. I need to see that you know what you're trying to do, okay? Now I can go back and I can start plugging in some numbers, okay? Don't forget that negative. And I gave you 250 milliliters of water. So I need mass of water, 250 milliliters of water, and that's 1 gram per milliliter. So I just end up with 250 grams of water. That's handy. So that's negative 250 grams of water times the specific heat of water, which is, you look up on the table, it's 4.18 joules over grams degrees Celsius. Okay? And then the last one is delta T, which is final temperature, which is 70 degrees Celsius, minus the initial temperature, which is 75 degrees Celsius. Okay? And we divide this by 22, the mass of the unknown, 22 grams, times the temperature, the delta T of the unknown, which is 70 degrees, that's the final temperature, minus 0.0 degrees, which is the initial temperature of the water, of the unknown. Okay? And you calculate all this stuff out, and you get 3.39 joules over grams degrees Celsius. All right, let's show that. Grams of H2O cancels, degrees Celsius cancels with these, and then I get joules over grams of the unknown times degrees Celsius of the unknown. All right, now what about Sig Figs? All right, so this number has 3. This has 3. It's given to you. Okay, this has 3. When I do the subtraction, okay, I'm going to have to round to the ones place. So I got 2 here. And when I do this subtraction, I'm going to have to round to the 1 place. And my answer is 5, so I'm going to actually end up with 1 sig fig. So that's just 3 joules over grams degrees Celsius. Now you do have to be a little bit careful with sig figs in this unit, all right? Be careful with the addition subtraction thing.